All right, welcome to the Titration Video Podcast. And I guess the best way to start this video podcast is with a definition of titration. What is a titration? Well, a titration is a very carefully controlled determination of the molarity or the concentration of an unknown acid or base. In this case, for today, it's going to be an unknown acid. It's hydrochloric acid. And we want to know the molarity. That's what we want to know. We want to know the concentration of that hydrochloric acid. It's an unknown at this point, but we're going to use a known concentration, a 0.1 molar concentration of sodium hydroxide, and we're going to use that known concentration of base to determine the concentration of the hydrochloric acid. And I'll show you the technique for that in just a moment. Before we do that, I just want to show you how to prepare for the titration. As you come to the apparatus, you're going to notice a tube, a long tube called a burette, and it's mounted actually upside down, so we'll remove that. The reason it's upside down is to drain any liquid that was there from a previous experiment. So we'll just turn it upside down. As we do, we'll notice that there's some very small gradations. This is a 50 milliliter burette, and we're just going to mount it back on the platform just like that with the device here called the stopcock in the horizontal position. That will prevent fluid flow through the burette, and we want that at this point in the horizontal position. I'm going to now clean the burette with some distilled deionized water and just kind of go around the sides of that, just like that. Just around the sides, just like that, with some distilled deionized water. Okay? And then allow it to run through the burette by opening up the stopcock just like that. It just takes a few seconds, doesn't take very long at all. The next thing I'm going to do is I'm going to, after I've washed with distilled water, I'm going to just do a quick rinse with the titrant. In this case, it's a base. It's sodium hydroxide, so I'll use a funnel so I don't spill anything. You don't need a full burette to do the cleaning. Just a little bit, just a few milliliters, 10 or 15 milliliters, something like that, to make certain that that burette is absolutely clean. And I'll just let that run through just like that. Okay? All right, we're going to leave this burette now. We're going to go to the burette on the right because I've already loaded it with the titrant. It's got 50 milliliters of sodium hydroxide, 0.1 molar sodium hydroxide in it. And what I'm going to do now is I'm going to place into this flask my unknown concentration of hydrochloric acid. I'm going to use a very precise amount of hydrochloric acid. It's 20 milliliters, so I'll just drop 20 milliliters into the flask, just like that. Then what I'm going to need to do is I'm going to need to add an indicator. In this case, my indicator is called phenolphthalein. It's clear at acidic pHs, but at basic pHs, or even a neutral pH, slightly neutral pH, it'll turn slightly pink. And I'll just add 2 or 3 drops. We don't need much, just a couple of drops will be fine. And so now I've got my acid of unknown concentration together with the phenolphthalein in the flask. I'll just stir it just around just a little bit, and I'll place it under the burette. And now what I'm going to do is I'm going to begin the process of the titration. In order to do that, I'm going to use my dominant hand. I'm right-handed, so I'll use my dominant hand to swirl the liquid inside of the flask, and I'll use my non-dominant hand, my left hand, to open up the stopcock. Now, as I'm doing that, first of all, I'm noticing at this point no pink whatsoever. That's not unusual at the very beginning of the titration. And I don't want a hot pink. I don't want a very dark pink. I just want a very light pink because I don't want to overshoot the titration. But while that is happening, I just want to go over what's really happening here. In the flask that I'm holding in my right hand right now are millions and millions of hydronium ions. That's from the hydrochloric acid that's in the water. Many, many hydronium ions. In the burette is hydroxide. That's sodium hydroxide in an aqueous solution. So OH minus ions are now entering the flask slowly. Okay? As they do, the flask is becoming more and more basic. Now at this point, because I'm not seeing too much pink, as a matter of fact I'm seeing a little bit, but not too much, the solution as a whole is still acidic. But as I begin to add more and more base, more and more hydroxide ions from the burette to the flask, what I'm seeing is that I'm seeing some pink now It's not a sustained pink just yet, but it's getting very close. I'll just slow it down just a little bit. So what I'm seeing now is that I'm approaching neutrality. I know that because the phenolphthalein is telling me that. The phenolphthalein, because it's turning pink, the solution is turning pink, is telling me you are now approaching a pH of 7 in this flask, because the number of hydronium ions in the flask is beginning to approximate the number of OH minus or hydroxide ions. Okay? I'm getting some sustained pink now. I'm not there quite yet, but I'm getting close. I'm going to just shut it down just momentarily. I can see that when I stop and then swirl, that the pink does remove itself. As I swirl, it does remove. We want a light pink, but a sustained pink. That tells us we're at neutrality. I'm not even at this point bothering to check what volume I've added, because it really doesn't matter. I'm not going to stop until I've reached that point of neutrality. We call that the end point. The end point. That's the point at which I can see that there's no longer any reduction of that pink, and I think I'm there. Now I'm at the point now where I have to be very careful. Okay, I'm at the point now where one drop will take me to neutrality. 1 or 2 drops will take me to neutrality. So I'll open up the stopcock, but only very slowly, just like that. There, and I'm there. I can see that it's a sustained pink. Even upon swirling, it sustains itself as a pink color, and I know now that I'm in neutrality. What I'll do now is I'll just stop the swirling and I'll look to see what the volume is that of the base that I've put into the flask. And as I look up here, I'm seeing it's about 20.6. In fact, 20.6 milliliters of base to completely titrate this acid. So, I'll see you on the next video podcast. We'll do the calculations for this particular titration, but that's basically how we do a titration in the laboratory. So I'll see you on the next one. Thank you.